So here we are going to discuss about architectural design in software engineering. Introduction means design has been described as a multi-step process in which representations of data and program structure, interface characteristics and procedural detail are synthesized from information requirements. Design is an activity concerned with making major decisions, often of a structural nature. Design builds coherent, well-planned representations of programs that concentrate on the interrelationships of parts at the higher level and the logical operations involved at the lower level. Software design model. This is the design model. First, we should there is various types of design model. It's information model, functional model, and behavior model. Then we'll move to the design. We should add some other requirements also. So data design, architectural design, procedural design, the various types of designs also presented here. And we move to the after the design, we move to the coding part, and coding part we should add some program modules. Then enter to the test. In this case, we have to validate the software is either okay or not. So the test should be happen. So steps. First begins with architectural design, then data design, then architectural structure of the system. Then analysis of alternative architectural styles or patterns, selection of alternatives and elaboration of architecture. So finally, what is software architecture? Before that, what is architecture? It is a program or computing system is a structure or structures of the system which comprise software components, the externally visible properties of those components and the relationships among them. The architecture is not the operational software. Architectural styles. Each style describes a system category that encompasses a set of components that perform a function required by a system, a set of connectors that enable communications, coordinations and cooperations and among components, constraints that define how components can be integrated to form the system, and semantic models that enable a design to understand the overall properties of a system by analyzing the known properties of its constituent parts. Data-centered architecture. Data-centered architecture constraints that define how components can be integrated to form the system. Semantic models that enable a designer to understand the overall properties of a system by analyzing the known properties of its constituent. Data-centered architecture, data flow architecture, call and return architecture, object-oriented architecture, layered architecture. So data-centered architecture in the sense it should be connected with various types of client software. The center store should be in data center. So data flow architecture there should be a various types of filter or pipes and filters are there. It shall just make some flow to reach the data. Call and return architecture means once we give the input, we just get the output regarding the same input. We just get some response from that device. It's layered architecture. Every single layer should processed and done with some outputs, and the outputs taken to the next layer of the input. So this is the layered architecture. So mapping requirements into a software architecture. Customer requirements. Earlier has said certain models can be mapped redirecting into an architectural design. Methods do not exist for all architectural styles. We'll look at an approach for the call and return architecture, sometimes called structured designs. Origins in top-down design. SD is a data flow oriented design method, provides a method to go from a DFD to program structure. So objectives of the design is to develop a modular program structure and represents control relationship between modules. Approach, the DFD is mapped into a program architecture. The PS, PEC and STD are used to indicate the content of each module and structure chart. It provides a convenient transition from a data flow diagram to software architecture. The type of information flow is established. Flow boundaries are indicated. The DFT is mapped into program structure. Control hierarchy is defined. Resultant structure is defined using design measures and heuristics. The architectural description is defined and elaborated. Thank you.